So here's a problem called the mutilated chessboard. I know it sounds dramatic and extreme. It sounds like a metal song or something like that. But basically, it's not that scary. So here's the basic premise. You need a chessboard, or you can use graph paper, or you can use a printout of chessboard. So chessboard has 8 squares on each side like this, and 8 times 8 is 64. So we have a total of 64 squares here. And the other thing we need are tiles. In this case, I'm using dominoes, and I'm using this particular chessboard because these dominoes pretty closely cover 2 squares like that. The question is can you cover the chessboard with dominoes completely if there are 2 pieces missing, one from each corner? Now, we should probably take a step back and say, can we do this problem using dominoes with just a regular chessboard? None of that mutilated stuff. This is a whole chessboard. So we can start placing dominoes in whatever pattern we want, and you can go ahead and try it at home. You can use graph paper, and we start laying out the pieces and just seeing, is it possible to cover the whole thing? And then we can go on to consider a more difficult case. So here's one possible solution to the chessboard problem. We can see that, yes, we can cover the entire chessboard with dominoes or tiles and completely cover it. So we've shown one solution. That means that it's possible. There's a lot of other solutions. I don't know how many. Maybe you want to figure that out just for fun. Now the question is, if I remove 2 opposite corners of the chessboard, can I still cover it with dominoes? We'll take 1 domino out because we won't need it. Obviously, if we remove 2 squares, the domino covers 2 squares, so we don't need that one. So is it possible to cover this chessboard using this many dominoes, cover it completely? Now, give it a shot. You can play around with it and see if you can come up, with a solution. Maybe you can't. And I'm curious if you can gain any insight into why or why not it's possible. And it doesn't matter which corners. It could be these 2 corners. It could be these 2 corners. It does matter if they're opposites. So let's naively give that a shot. Okay, I'm going to say these 2 ones are missing. So let's try some pattern. Can't do that. Let's try again. Oh no, again, we can't touch this one, and we can't put the domino like that. That's not allowed. So again, we're stuck. Now we could keep trying this, and maybe we'll find a solution. Maybe we won't, but maybe we should step back and just give a think about it. Or, if you're the type of person who just likes to keep charging forward, go ahead and keep at it. But I'm curious if you can see if there's a reason why you think it'll work, or if there's a reason why not. Because sometimes with problems, you might not have time to just keep banging your head against the problem until you find a solution. Sometimes you got to be clever about it and see if you can figure something out. So go ahead and see if you can figure out some reasoning why this might work or might not work. When we look at the chessboard here, here's some things that we notice. One, whenever we put a domino on, it's going to cover 2 spaces on the chessboard. But also we notice that no matter how we lay a domino on, it's going to cover one dark square and one light square. Your chessboard might be a different color. On here, we'll just say it covers one black and one red. Okay, and so that's an important thing to notice. And the other thing, our restriction, we said, is we're going to do opposite corners. So notice that both of the opposite corners here are the same color, and the same thing here. They're the same color. So that means, remember, we have 8 squares on this side and 8 squares on this side, and 8 times 8 is 64. So we have to cover 64 squares minus the 2. So there's 62 left. And we took away one domino. We had originally 32, so now we have 31. Well, 31 times 2 equals 62, so it seems like we should be able to cover it. However, we made the observation that the opposite corners are the same color, and we also made the observation that a domino must cover one black and one red. So if we take away the 2 black ones, that means, what do we have? How many do we have? We don't have the same amount of black and red ones left. We're actually down 2 black ones, but we have the same amount of red ones as we started with. So there's no way that we could ever solve this problem. It's impossible. This is also important mathematically because what I just explained to you, the reason why it can't work, is something that we call proof, even though that was a fairly loose proof. I just explained it to you, but a proof basically is just an explanation. It's making a convincing argument why or why not something is true. Now, this is an important thing, and it's something that you should definitely practice in any of these problems. When you come up with a solution, is it's easy to convince yourself that something is true because you're like, aha, I got it. And somebody else might not be so ready to accept that, you know. So try convincing somebody else. Try convincing a friend, see if they agree with you, or maybe they have some counter example or something like that that maybe you have an answer for, or maybe you hadn't thought about. And that's an important thing too. And then also it's important to try to prove people who are skeptical as well. Now, the wonderful thing about mathematics is when you have a conjecture, we call theories, what we call hypotheses in mathematics, we call them conjectures. It's when you believe something is true or not, and you have good evidence for it, you've seen the patterns, it seems like it makes sense, and you create a step-by-step logical argument for why you think what it is, and everyone who reads it can see, aha, this is correct or not, or they might actually point out that you made a mistake somewhere. And pretty much when something is proven in mathematics, it becomes a theorem, and that's it. I mean, there's really no there's no ambiguity anymore. You know, once something is logically shown to be true, and the steps follow from the basic assumptions that you made, then it goes into the history books, basically. It goes into the math books, and that becomes something that's accepted and people will use later on to prove other things or solve other problems. So it's a little bit different from science in that way. Generally in science, you can try to prove something as being true, or better yet, you try to prove something isn't true. And if you fail all the time to prove something isn't true, then it might be true, and that's generally the best you can say about a scientific theory. And we keep looking for new evidence. You know, science is empirical. It's based on evidence. But mathematics is a little different because it is not necessarily based on what we understand empirically, but it follows from what's logical. Anyway, I hope you found that problem interesting. That was the mutilated chessboard. Thanks.